Okay, so here's how I would balance this equation. I'm going to start with carbons since it's over on the left there, and why not? So I've got 8 carbons on the left side of my arrow. How many do I want to end up with on the right? 8. So the first thing I could do is try an 8 right here. Now I've got 8 of that entire molecule. In other words, I've got 8 carbon dioxides. 8 CO2s that were produced. Okay, fine, that's wonderful. We'll leave it like that for now. Now I'll go back over to my left side. Which one do I have to balance next? I've balanced my carbons now. I got 8 carbons on the left. I'll have 8 CO2s, each containing 1 carbon on the right. So I got 8 carbons on the right. My carbon atoms are now balanced. How about hydrogens? How many I got on the left? 18. How many I got on the right? 2, because every water has 2. So remember, water is H2O. H2 means I got 2 hydrogen atoms. So if every water contains 2 hydrogen atoms, how do I get 18 total hydrogen atoms over here? Yeah, I'll throw a 9 right here. See how I did that? In 9 waters, how many hydrogen atoms do I have? I got 18. Because every water contains 2 hydrogen atoms. So if I take 9 of these at a time, it's 9 by 2. I get 18 hydrogens. So now I got 8 carbons here, 8 carbons there. I'm all set. I've got 18 hydrogens here. I've got 18 hydrogens there. So far, so good. All set. What did I say for last? I got oxygen over here. That's my last one because I left the one that's a loner all by itself because it's going to be easiest to balance at the end. Let me show you what I mean by that. How many oxygens do I have in this CO2 right here? 16, because I got 8 of total of these CO2s, each containing 2. 2 by 8, that's 16 oxygens there. Plus another 9, what does that get me? 25?
Yeah.
It's 25. Right? Because I got 16 here, plus another 9. That's 25. Okay, so I have 25 oxygens over here. Can I make this be 25 over here by adding a coefficient? Oh, so I got a problem. Doh. I actually picked a really hard one to balance. This one's annoying to balance. What do I got to do here? I got an odd number on this side, so how do I make it into an even number? I got to multiply something by 2. I got to take an odd number and multiply by 2. So instead of a 9 right there, what should I probably write? 18. Shoot. So now what I'm going to do is I'm going to go and I'm going to erase my 9. Nope, I'm going to erase it down here. No, that'll work. All right. And you see how this works? Like kind of like those Sudoku puzzles. Like you go back and erase stuff and try something else. You know. So I'll put an 18 there. All right, I did that. Hooray! Now I've got. I can easily balance my oxygens now. Except what did I do when I did that? I screwed up my hydrogens. Ah! Shoot. So wait, before I go and handle that last little O that's hanging out all by itself on the left side of the arrow, let's go back here and refix my hydrogens. If I've got 18 hydrogens on the left, and now I've got what, 36 on the right? So what am I going to do to make that 36? I'm going to have to take 2 of those. Phew, now my hydrogens balance again. I've got 2 by 18 on the left. I've got 2 by 18 on the right. I'm good to go. Except when I did that, what did I just screw up again? Ah, my carbons are screwed up now, so now I got to go back over here. I've got 2 by 8. I got 16 over there. So I'm going to change this 8. I'll change that 8 to a 16. Whew. We're getting there. We're almost there. Now we're on to something, though. Let's go back and double check. Is this balanced? I got 2 times 8 for carbons. That's 16 carbons over there. I got 16 carbons over here. I've got 2 by 18. That's 36 hydrogens over here. I got 18 by 2, 36 hydrogens over here. The only thing that's not balanced now is I got 16 by 2. That's 32. Plus 18. That's 50. Right? I've got 50 total oxygens on the right. What's that?
25? What are the other two?
I got 50 total auctions over here. 16 by 2 is 32 plus 18. That's 50. So can I make this into 50? What do I put in front of it? 25, and we're good to go.
Wait, why couldn't we do that earlier though?
That is really what's going on. When you, so like when you're driving a car down a road, for every 2 gasolines, this is what this means. This is why balancing is important. So pay attention now. If all of that missed you, we're going to do some more example problems here in a minute. And that one was like super hard. If you followed all of that, you're good to go. If you didn't follow all of that, we're going to do some easier ones, and it will all make sense to you in a moment. Okay, this right here is gasoline. So when you're driving your car down the road, this is why this is important. For every 2 units of gasoline I take in, I'm going to have to take in 25 units of oxygen. So that's why people use this. People that are worried about automobile emissions, like how much carbon dioxide is going to come out of the tailpipe. Well, if I know how much gasoline is going in, I could figure out how much carbon dioxide is coming out. You get it? You start being able to use this for actual practical things that people in industry worry about. That's one of the reasons why you have to learn about stoichiometry. Is if you want to go do this stuff, you want to work for a company someday that makes anything, they worry a lot about stoichiometry and balancing equations. All right, like I said, if you get that, you're good to go. If you don't, we've got a little bit more practice that I'm going to do with you.